All right, everybody, welcome to the video here for the second Regents review assignment. So for this assignment, we are going to go ahead and start to review some of the factoring methods that come up on the Algebra 2 Regents exam. Now, if you remember in class, we went over lots of different factoring methods. The main one that comes up on the Regents exam is factoring by grouping. However, within some of these problems, you might see some of the other factoring methods pop up. So let's just jump right into it. So for the first question, it asks you for the zeros of the function. Now, it's a quartic polynomial, so we know that there's going to be four zeros. And to be honest with you, this being a multiple choice question is not even really a factoring question. It's more, can you use your calculator and see where this graph touches the x-axis? Because that's what it means when it says zeros, right? So the zeros are going to be your x-intercepts usually. So if we go ahead and just graph that in the calculator, we should see some type of quartic polynomial, and we should be able to see where it intersects the x-axis. That'd be the easy, quick way of answering this because it's multiple choice. But that's not what I'm interested in for this assignment. I want to see if you could actually factor that expression. So to find zeros, we set the equation equal to 0. And let's see if we could actually factor this out. So the first thing I notice is that all four terms have an x, so there's a common factor. So I'm going to take out x. I'm just using just the basic GCF method there, saying that x is the common factor, so I can take it out. Then I'm going to try and factor this expression inside. I see that there is four terms, so that's going to tell me grouping. So I'm going to group this. And I'm going to look at the first group and say that the GCF is x squared, leaving us with x minus 4. I'm going to take a look at the second group and see that the GCF is 9, but I could either take out a positive 9 or a negative 9. I'm going to factor out a negative 9 to make it so that that expression x minus 4 is the same. That's kind of like the golden rule of factor by grouping. We want this parenthesis to be the same in both spots. So now that it is, I can group this up. Don't forget about your x. So the x comes down. Our common factor goes first. And then whatever remains after taking out that common factor goes inside. So to continue factoring this, I see another factoring method that pops up here, x squared minus 9. So I could say, well, I could factor that further to give me x minus 4. And then x squared minus 9 factors by difference of two squares. So I know it's going to be x plus and x minus. And then I'm asking myself what multiplies to itself to make 9. So that would be 3 and 3. This is all still equal to 0. Now, if this was just a factoring question, we'd be done. We've factored completely. But this does ask us to find the zeros. So I'm going to add, set each parenthesis here equal to 0. It's important to remember that you're setting these equal to 0. You're not just like switching numbers around, which I know some of you got into a bad habit of when we did this back in the early part of the course. So if we do some quick algebra, we get another answer there. We have 0, we have a 4. We can subtract 3, and we now have a negative 3. We can add a 3, and we now have a positive 3. So we have our four answers. So x is equal to negative 3, 0, 3, and 4. So now I have to figure out which choice gives us all four of those answers. So I have a plus and minus 3, I have a 0, and I have a 4. So that would be choice A. Number 2 is another multiple choice question. This one's really about factoring, though. Like, do you actually know how to factor? So let's go through each one. So for that first one, 4k squared minus 49, that's difference of two squares. I see perfect squares, I see subtraction, I see even exponents. That tells us what we're doing. So I'm going to say what multiplies to itself to make 4k squared. That would be 2k and 2k, so that's good. It's a plus and a minus. That's good. And then what multiplies to itself to make 49 is R7 and R7. This one is good. Choice B is difference of two cubes. Now, if you don't remember from class, when we factor difference of two cubes, I probably made it b cubed minus b cubed, a cubed minus b cubed, and said it's a minus b times a squared plus ab plus b squared. And that first parenthesis is always created by saying, what do I cube to make those numbers? Same sign. Then it's square multiplies square. And if we remember the rule of SOAP, that tells you the signs. Same sign, opposite sign, always positive. So does this one work? So what do I cube to make a cubed would be a, that works. What do I cube to make 8b cubed would be 2b, so that works. I square a squared, that works. I multiply these two expressions together. A times 2b is 2ab, that works. And I square 2b, which becomes 4b squared. So that works. So the numbers and the variables are all good. Let's talk about signs. Are the signs the same? Opposite, always positive? Yes, they are. So that one's factored correctly. For the next one, I see 1, 2, 3, 4 terms, so I'm thinking grouping. So I'm going to start by saying, well, that has m squared as a common factor, leaving with m plus 3. Well, here's where I run into an issue. I can't factor this in any way to make m plus 3 in that parenthesis. If I decide to take out negative 4, that's going to give me m minus 3. That's not the same, so that's no good. If I take out positive 4, that's going to give me negative m plus 3. Neither of those is going to give me the same factor here. So that is actually factored wrong. The last one, which when this was on the Regents exam, a lot of students chose because it had so many different things here, but it just got 6 terms, so you could break it up into 2 parts of 3. It's still grouping, so we have t squared plus 5t plus 6. And on the other one, we have nothing, so we'll say 1, right? If there's nothing in common, there's always 1 that's in common, so we could take that out. And notice the grouping works. We get the same parenthesis twice. So we could say, here's my common factor. And then what remains? And then we could still factor, which is why this answer has 4 factors in it, because this expression is factorable using that MA method. What multiplies to make 6, but adds to make 5. And the numbers that make that work are going to be 2 and 3. And we get something that factors the same as that. I know it's in a different order, but multiplication is commutative, so we are good to go. C's our answer there. All right, so number 3 is a free response question. So it says to factor completely. As soon as you see this word in a free response question, it means you're probably going to have at least 2 steps. So you're not just going to factor 1 and done. It's going to be 2 steps of factoring or more. Luckily, I see 1, 2, 3, 4 terms again, so I know what to do. It's grouping. So if I group those first 2 terms, I get x squared. And I'm going to be left with 4x minus 1. If I group these last 2 terms and say what's the common factor, I get positive 4, which also gives me 4x minus 1. Well, then I can combine with our common factor, so we have 4x minus 1, and we're left with x squared plus 4. And actually, at that point, we are done. It says over the set of integers, so we don't have to factor this last expression with imaginary numbers like we might have done in class, because it says integers. Integers don't include the complex numbers. So we're finished. Next one's a little tricky. So it says it's 4 terms, but if I start grouping, I get a common factor of x, giving me x plus 3y. I get a common factor of 1, giving me 3x cubed plus y. These are not the same. So then we say, is grouping wrong? Well, the answer to that question is no. It's still 4 terms, so grouping's got to work. I just might have to reorder my term so that it actually groups correctly. So one of the things that you should see right away as soon as you notice this is not written in standard form. In standard form, we want to put the biggest exponents first. So if I rewrite this as 3x cubed plus x squared again, using that good friend of ours, that commutative property, plus 3xy plus y. Now, if I try and group it, it should work. So if I try and group this, the common factor in these first two terms, now that I've reordered it, is x squared, leaving us with 3x plus 1. In the second group, the common factor is positive y, also leaving us with, you guessed it, 3x plus 1. So now we have that common parenthesis, so that common factor of 3x plus 1 can factor out, leaving us with x squared plus y. And we're done. So again, a little tricky there because you actually had to reorder your terms. Last question. I see 1, 2, 3 terms, so this is not grouping. So this is going to be the Ma method. So what multiplies to make negative 12, but adds to make negative 4. So I have to think of numbers that make that work, which would be negative 6 and 2. Here's the problem. We don't have x squared, we have x to the 4th. So when I factor this, I have to not just put x's in there automatically, I have to think what multiplies to itself to make x to the 4th. X squared times x squared would be x to the 4th. So I'm going to put x squared in that first spot. And I'm going to put minus 6 and positive 2. And I'm done. There's nothing left to do there. There's no more factoring left. Hopefully this video helped. Hopefully you actually tried this before you actually watched the video and you're like, hey, I got a bunch of these right. If you have any questions, ask me in class and get ready for your weekly quiz.